Alright, these are the notes for Algebra 2, Section 8.6. We are solving rational equations. We've already seen how we can add and subtract rational equations, multiply and divide, etc., etc. So now we're going to actually solve equations using rational expressions. The first thing that we can do to solve a rational equation, if it's possible, is to cross-multiply. Now, cross-multiplying can be used to solve a rational equation if each side is a single rational expression. You'll notice in our example here we have 1 over x equals 2 over x plus 3. Each side is a rational expression, therefore we can use cross-multiplying to solve it. Well, let's see how that would work. Cross-multiplying is something that we've seen before, but never quite in this context. Now here I want to change one thing really quick. Your note guide has 2x minus 5 on the bottom, so I'm going to go ahead and change this to 2x minus 5 so that we're working out the same problem. And from here we want to use cross-multiplying to solve this equation. I can use cross-multiplying because I have a rational expression here and a rational expression here. Cross-multiplying means I'll multiply the numerator 20 by the denominator x minus 2, and I will multiply the numerator 5 times the denominator 2x minus 5. That's cross-multiplying. Once I've done that, this is a fairly standard equation. I can solve this. I will start using the distributive property, so I will distribute the 20 and the 5. 20 times x is 20x. 20 times negative 2 is negative 40. On the other side, 5 times 2x is 10x. 5 times negative 5 is negative 25. Again, a fairly standard equation. We need to get this 10x to the same side as the 20x. And to do that, we will subtract 10x from each side. Now, at this point, and from this point forward, we are looking at standard solving equation stuff. None of this is new material, so it shouldn't be difficult for you. You should know how to do this. We've subtracted 10x from both sides, giving us 10x minus 40 equals negative 25. And from here, we need to add 40 to each side. This is a two-step equation. We always add or subtract before we multiply or divide. This leaves us with 10x equals 15. Our last step then would be to divide by 10 to get x by itself, and x equals 1.5. So this is our solution. One thing we might want to do, though, is check to make sure it actually works. Rational expressions can be a little buggy. We might get the wrong solution for one reason or another. So we don't want to have to worry about that and then see that our answers are completely wrong, etc., etc. So let's go ahead and check our answer. I've crossed out the 3's and replaced them with 2's. Again, so we're doing the same problem. I think on your note guide, it's also incorrect. There was a mistake in the copying. You know, no one's perfect. To check this, all we need to do is plug in our solution, 1.5, in for x on both sides of the equation. Now, in order for this to be a true equation, both sides of the equation have to be true. Now, we would type this into a calculator. We'd plug this into the calculator on top and on bottom. And I'm going to sort of be like one of those old cooking shows where they say, oh, here's one that I prepared an hour ago, because I've already plugged this expression into the calculator. And what I got on top and on bottom was negative 10. All right, let's move forward. I have, let's see, x over 8 plus 11 over 3 equals negative 14 over x. Now you might notice immediately that there are two rational expressions over here being added together, and then one rational expression on the other side. This poses a problem. I can't cross multiply. I cannot cross multiply because I don't have one rational expression on each side of the equation. I have two on this side. So instead, I want to use the LCD to solve this. And here's how this is going to work. First, I need to find the LCD. To find the LCD, we start with the first term, x. So x has to be in our LCD. We look at the second denominator and we say, okay, what's in this denominator that's not in the LCD? And it looks like that's 3. So we'll have 3 times x, so 3x. What's in the third denominator that's not in the LCD? And the answer is nothing. The LCD 3x, I'll rewrite that so it looks a little bit nicer. The LCD 3x already has an x in it. My LCD then is 3x, and I want to multiply both sides by 3x. So I'm just going to multiply everything in the equation, every single expression, by the lowest common denominator, 3x. Now when I do this, interesting things happen. For instance, I get 24x over x for the first one, and I get 33x over 3 for the second one. Remember, when I multiply, I multiplied the whole number by the numerator. On the other side, you might notice that this x and this x cancel out. So 3 times negative 14 is just negative 42. Now I would like to simplify this here. 24x over x, these x's cancel out, leaving me with 24. 33x over 3, 33 over 3 becomes 11. So I'm going to rewrite this. You might not want to erase your work, but instead write it off to the side. 24 plus 11x. Now this is an equation that we can solve. It's a two-step equation. And of course we're going to solve for x. We subtract 24. I don't know why I wrote 142 there. That's a little odd. It's not 142. 3 times 14 is negative 42. Leaving me with negative 66 here. 11x equals negative 66. We, of course, divide by 11. And the solution is negative 6. And we can check this guy in the original equation as well if we want to.